Welcome to my channel Glory with Mathematics. Please subscribe, like and share.
Dear students, so let us start the topic irrational numbers from the chapter number system. So already you know about rational numbers. The rational numbers are the numbers which can be represented in the form of p by q, where p and q both are integers and q is not equal to 0. So there may be numbers on the number line that are not rationals. So in this section we are going to investigate these numbers, the numbers which are not rationals. So already you know the numbers. So far you know the numbers. Those are in the form of p by q, where p and q both are integers and q is not equal to 0. So you may ask, are there numbers which are not in this form? That means the numbers which are not in the form of p by q, where p and q both are integers and q is not equal to 0. Yes, there exist some numbers which cannot be represented in the form of p by q. So these type of numbers are known as irrationals. So these numbers cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So in this section we will discuss about irrational numbers. So some examples of irrational numbers are root 2, root 3, root 15, pi and 0.101111 like this. All the non-terminating and not repeating decimal numbers are irrational numbers. So later we will learn about this. So irrational numbers, the numbers which are not rational, those numbers are known as irrational numbers. Then the collection of all rational numbers and irrational numbers together make up the collection of real numbers. So already you know about rational numbers, the numbers which are in the form of p by q, where p and q both are integers and q is not equal to 0. And irrational numbers, the numbers which are not rational, those are irrational numbers. So the rational numbers and irrational numbers together make the real numbers. So which is denoted by capital R. So therefore a real number is either a rational or irrational. We can say that every real number is represented by a unique point on the number line, and its converse is every point on the number line represents a unique real number. So these two sentences are converse of each other. Every real number is represented by a unique point on the number line, and every point on the number line represents a unique real number. So we call the number line as the real number line. The number line on which we can represent real numbers, that number line is known as real number line. So this is the figure of our number system. Already you know about this type of numbers. First, natural number. Examples are 1, 2, 3 and so on. The numbers which are used for counting, those are known as natural numbers. Then whole number. If 0 is added with natural numbers, those are known as whole numbers. 0, 1, 2, 3 and so on. So all the natural numbers are whole numbers, but all the whole numbers are not natural numbers. That means natural numbers are included in the whole number. Then integers. All the negative numbers, 0 and all the positive numbers are known as integers. And natural numbers and whole numbers are included in the integer series. Then rational numbers. Natural numbers, whole numbers and integers all are included in rational number series. So, but some extra rational numbers are there which are not integers, not whole numbers and not natural numbers also. Then this big circle is the rational numbers. Then irrational numbers. The numbers which are not rational are irrational numbers. For example, root 2, root 3, root 10, pi, like this. And the combination of all the rational numbers and irrational numbers, they are known as real numbers. So real numbers are the collection of rational numbers and irrational numbers. Then let us solve an example. Locate root 2 on the number line. So how to represent root 2? Root 2 is an irrational number. So how to represent root 2 on the number line? So look at the figure. Here O, A, B, C is a square. So this is a square having one unit side, whose side is 1 unit each. So here OB is the diagonal of the square. So by using Pythagoras theorem, OB square is equal to OA square plus AB square. So that is equal to OA square, 1 square plus 1 square. This is equal to 2. So this implies OB is equal to root 2 unit. So this is root 2 unit. But we have to represent root 2 on the number line. So in this way, we have to represent root 2 on the number line. First, draw CB. So this is CB. CB is equal to 1 unit. Then draw AB perpendicular to CB, and AB is equal to 1 unit. Then join AC. So by using Pythagoras theorem, AC square is equal to CB square plus AB square. So that is equal to 1 square plus 1 square. This is equal to 2. So this implies AC is equal to root 2 unit. So then we have to represent root 2 on the real number line. So by taking O as center and by taking C as center and AC as radius, draw an arc, and that will intersect our number line at point D. So here CD is equal to root 2 unit. On the number line, CD is equal to root 2 unit. In this way, you can represent or you can locate root 2 on the number line. The next example, locate root 3 on the number line. So first step is same as the location of root 2 on the number line. So look at the figure. So here AB is equal to 1 unit. Draw first AB is equal to 1 unit. Then BC is equal to 1 unit. AB is perpendicular to BC. So here BC is equal to 1 unit. So this implies AC is equal to root 2 unit. So at point C, draw a perpendicular DC with AC. Draw DC perpendicular to AC and DC is equal to 1 unit. So here DC is equal to 1 unit. So we have to find AD. So AD square in triangle DCA. AD square is equal to AC square plus CD square is equal to root 2 square plus 1 square is equal to 3. So this implies AD is equal to root 3 unit. So we have to represent root 3 on the number line. So by taking A as center and AD as radius, draw an arc which intersect the number line at E. So here AE is equal to root 3 unit. So in this way we can locate root 3 on the number line. So in the same way you can locate n for any positive integer root n after root over n minus 1 has been located. Because here we locate root 3 after locating root 2. We can represent root 6 after locating root 5 on the number line. Thank you.